Good evening to all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on linear time invariant discrete time systems, that is block diagram representation. Empathy. Why do we need block diagram? It is used in digital signal processing in filters, equalizers and control systems. In embedded systems, we are integrating system from real-time control and monitoring. In MATLAB, Simulink software platform for simulating and analyzing the dynamic systems. In DSP process, specialized hardware for efficient signal processing tasks. For data flow visualization, visual aids for tracking data movement within the systems. And then digital signal processing, core technology for signal manipulation and analysis. Finally, difference equation, mathematical models representing system dynamics over time. This is the visual representation of difference equations. Simplify the understanding of data flow and system behavior. Used in MATLAB Simulink, DSP processor and embedded systems. It can be defined as y of n is equal to x of n into h of n. Next one, this is the defined part of block diagram representation. As the discrete time systems can be divided into direct form 1, direct form 2, cascade and parallel form. They are direct form 1s, they are of delays and coefficients. In direct form 2, there are shared delays and optimized structure. In cascade form, series connection and subsystems. In parallel form, parallel connections and subsystems. These are the elementary blocks to represent block diagram representation. First, adder x1 of n added with x2 of n, we can get x1 of n plus x2 of n. Constant multiplier x of n multiplied with constant, we can get it as your a into x of n. Unit delay element x of n multiplied with z inverse, we can get the output as x of n minus 1. Next one, signal multiplier x1 of n multiplied with x2 of n. Y of n is equal to x1 of n into x2 of n. Advancing element plus indicates advancing. X of n multiplied with z power plus 1, we can get y of n is equal to x of n plus 1. Multiplication x1 of n multiplied with x2 of n, which can produce the output as y of n is equal to x1 of n into x2 of n. What are the ideate part for exploring structures is nothing but direct form 1 for to separate input and output sessions. Direct form 2, reduced storage via state space form and optimized storage using state space. Cascade form, subsystems in series, output feeds next. Parallel form, subsystems in parallel outputs can be combined. Next one, this is the example of block diagram representation. Y of n is equal to y of n minus 1 into x of n minus 1 plus 0.5 into x of n. See, x of n multiplied with 0.5 that can be added with x of n minus 1 means it can be delay function. Therefore, z inverse means we can get it as x of n minus 1. That can be multiplied with y of n minus 1. Y of n can be given as output part. Multiplied with z inverse, we can get y of n minus 1. Therefore, finally, we can get y of n is equal to y of n minus 1 into x of n minus 1 plus 0.5 into x of n. Next one, h of z is equal to 1 divided by 1 minus a z inverse. X of n multiplied with the constant term 1. We can produce the output as y of n. Y of n multiplied with z inverse, we can get y of n minus 1. That is, again multiplied with a, we can get it into a into z inverse. This is the another block diagram representation. Next, we can see the direct form 1 structure. H of z is equal to 1 plus 2 z inverse plus z power minus 2. The whole divided by 1 minus 0.75 z inverse plus 0.125 z power minus 2. See, h of z can be represented by y of z divided by x of z. x1 of x of n multiplied with another signal, that is nothing but your 1 in terms of 2 z inverse means multiplied by z inverse, again multiplied by 2, we can get another signal. Again multiplied with z inverse we can get z power minus 2. Therefore, x of n function gets over. Y of n is equal to, we can get it as 1 multiplied with z inverse, again multiplied with minus 0.75, we can get 1 minus 0.75 z inverse. Again multiplied with z inverse, we can get z power minus 2 multiplied with plus 0.125, we can get as your output function as y of n. Next one, this is the direct form 2 realization. H of z is equal to 1 plus 2 z inverse plus z power minus 2. The whole divided by 1 minus 0.75 z inverse plus 0.125 z power minus 2. X of n multiplied with 1 we can get, that can be multiplied with z inverse, we can get 0.75. Again multiplied with z inverse we can get z power minus 2. Multiplied with 0.125 we can get it as an x of n function. Y of n is equal to, multiplied by 1 we can get it as 1, multiplied with z inverse we can get, multiplied with 2 we can get 2 z inverse, again multiplied with z inverse we can get z power minus 2, we can get the output function as y of n. See, cascade form means h of z is equal to 1 plus z inverse, 1 plus z inverse, the whole divided by 1 minus 0.5 z inverse into 1 minus 0.25 into z inverse. See, all the four functions that can be realized using the series function. The series functions are combined, we can get it as a cascade form realization. In terms of parallel form means, we can take the partial fraction method, find out the values of a, b, c. We can get it as a final output as h of z is equal to 8 plus 18 divided by 1 minus 0.5 z inverse minus 25 divided by 1 minus 0.25 into z power minus 2. 8 and then constant multiplier 18 and then minus 25. It can be realized by using the parallel structure. We can get it as your output as y of n. Next one, mind map. How it is related with your mind map means, block diagrams are used in digital filter design that can be designed digital signal processing filters. It is used in control system, that is nothing but with the help of feedback loops enhances the performance and stability. It is used in communication systems. Block diagram facilitates communication receiver transmitter design, and it's used in control system design, DSP hardware, and essential for filter and control implementation, essential for implementing DSP hardware, and then visual debugging and optimization of signal paths to debug the system issues. Next one, we can see the assessment. Define block diagram. The discrete time systems are represented by block diagrams are called as block diagram representation. Mention the structures to represent block diagram. There are four structures: direct form 1, direct form 2, cascade form, and parallel form. The system transfer function of LTI dt system is defined as h of z is equal to y of z divided by x of z. List the summary of elementary blocks to represent DT systems, that is nothing but adder, constant multiplier, signal multiplier, advancing element, delay element, etc. Identify the difference equation. We can get it as your x of z is equal to 1 divided by 1 minus a z inverse. Thank you.